Picture this. What if, and I mean what if the software running the world didn't have to live on a handful of big company servers anymore, but could actually run on a shared global network that no single person or group actually controls? Imagine AI tools not just helping you brainstorm ideas, but actually letting regular people build and launch full apps that stay secure, private, and more importantly, available to anyone without actually depending on the usual tech giants. It sounds pretty different from, say, how things work today, doesn't it? I'd say so. But right now, in the space where AI meets crypto, there's one well-known project that just saw a big team walk away, saying the real decision-making didn't match the promise of everyone sharing power equally. That's got a lot of people asking tough questions about who actually holds the keys in these systems. I can tell you, I've spent years watching how money and big tech systems operate, and moments like this feel familiar. They're talking like old patterns showing up in new clothes, because most projects talk about tokens and rewards, but one stands out because it tries to handle the entire software setup right on chain itself. And today, we're going to break down what happened in that other project. Look closely at how this different approach is built and actually see why the way that something is put together from the start can matter more than the loud stories around it. Okay, so stick around, because by the end of this video, you will have a crystal clear view of what sets these designs apart in the world of artificial intelligence and decentralized tech. Because in this video, we're taking a calm step-by-step look at how some crypto projects are trying to blend artificial intelligence with blockchain in practical ways. Well, we'll start with a recent real-world example from Bit Tensor network that shows the kind of challenges that can pop up even when everyone talks about being fully open and shared. And then we'll explore also the Internet Computer Protocol, often called ICP or the World Computer, and how its setup aims to run complete software, applications, data, and artificial intelligence tasks entirely fully on-chain without leaning on outside external centralized services. And I'll weave in a few observations from my time following traditional financial markets, because those experiences that I had helped me spot why certain structures hold up better over time. And that's fundamental here. You have simple analogies, everyday examples, and clear explanations. So even if you're new here to all this stuff, it all makes sense. No hype, no promises, just the facts about the designs and trade-offs and what they could mean for how artificial intelligence and software might work in the future. So by the end, you might look at these technologies with, say, fresh eyes and a better sense of why the behind the scenes architecture is what really counts in regards to mass adoption. And when things get complicated, you'll understand why. Let's start with a challenge that just unfolded. A short while back, one of the most active teams in the Bit Tensor network, called Covenant AI, announced they were leaving, completely. The founder posted publicly that after doing some serious work, we're talking about like helping run one of the biggest decentralized trainings for a large language model, they felt the actual control didn't line up with the project's message of true shared power. This is key here. They pointed to situations where a co-founder still seemed to influence key decisions through a small group setup for upgrades and rewards, getting paused on They're parts of the network, and also some timing around token moves that felt just like extra pressure. The whole thing caused the project's token to drop noticeably in a short time, and the community also split between surprise and debate here. The co-founder then responded by talking about future changes like more independent subnets and longer-term ownership ideas. But the event left people thinking and scratching their heads about how fast growth can test the rules of any system. This isn't unusual in new tech spaces, but it does highlight a real problem. When a project promises no single boss, the actual governance rules have to back that up, or cracks can and inevitably show up. Think of it like a big group project at a school where everyone says it's equal, but one kid keeps holding the final pen. Eventually, people within that group notice and step back. I can tell you from my time observing traditional financial markets, I saw something very clear and similar play out more than once. Years ago, I watched companies rush to use the big cloud services for everything because it was just convenient and fast and simple. But when one main provider had an outage or quietly say changed their terms, whole businesses, I'm talking whole operations, felt the hit at once. And it taught me that depending on a few central points creates hidden risks, even if on the surface it looks smooth. The lesson wasn't about timing the market at all here. It was about noticing who really controls the pipes. And that same pattern helps me look at crypto projects today without getting swept up in the daily noise. It's frankly the truth. And now let's shift to a project that's trying to solve some of these exact issues. Because by building things absolutely different from its foundation, we're talking about the Internet Computer Protocol here. ICP, the world computer, was designed from the ground floor, from the start. The world computer, meaning it tries to handle not just transfer money, but we're talking full apps, websites, data storage, even AI processing, all inside the blockchain itself. Most or all the other chains focus on token or financial side, let developers use regular centralized cloud services for the rest. But ICP flips out by keeping the whole stack 100% fully on chain. The main building blocks, they're called canisters on ICP. And just picture a canister like a sturdy box that holds code, data, and even the front page you see in your web browser. Say, when you deploy one, it runs across many independent computers in the network. And the rules make sure at the same time the results are the same every time. No cheating or hidden changes. And this is done through something called chain key cryptography, which basically lets groups of nodes sign off on work as if they were one secure machine. It's not theory here. People are already using it for real applications. And one thing that makes it stand out is the governance in all this. And the governance system called the Network Nervous System, or NNS. Token holders can stake their coins, propose changes, and vote. Once something passes, it happens automatically on the chain. No small groups with secret keys can step in and override like in some other setups. That design tries to spread power more evenly over time. And there's also the internet identity, which lets people log in using their device's own secure keys instead of passwords. It feels simple for the user, but it's built on crypto, so it's private and hard to fake. And for connecting to other blockchains, it has direct paths to Bitcoin for CKBTC, CK Ethereum for Ethereum at the protocol level, not through wrapped copies. No, because they can break. All of this here aims to remove the usual middleman in the process. And let me make this crystal clear. This even is clearer with another story that I can tell you from my traditional financial experience that I do remember watching in the early days of online stock trading. Obviously, my background is in traditional finance. Some of them, they started out promising to cut out the big banks and give regular people actually direct access. But many still ended up routing through the same few clearinghouses or data centers that they were used to. Because when those central spots had problems, what happened? The whole experience slowed down or even stopped. The projects that lasted the longest were the ones that built more of their own infrastructure instead of renting it out. And that's the key fundamental difference here. It wasn't about being flashy at all. No. It was about owning the full process. So surprises didn't break everything. That's key here. And that's a kind of thinking that helps me appreciate why keeping the entire software stack on one secure network actually matters. Now let's talk about the artificial intelligence side, because that's where things get very interesting. We're talking AI tools today. Let almost anyone create code, images, or ideas super fast just by describing with natural language what they want. The hard part has always been taking that creation and actually running it for real users without paying big companies to host it. A system like ICP removes that second barrier by letting the finished app live and running right fully on chain. You could build an artificial intelligence agent that answers questions, processes images, or even runs simple games, and users reach it like any normal website. But the code is actually secured by the whole network itself. There's something called vet keys that keeps actually certain computations private end-to-end, and verified calls to outside data that the chain double checks. Recent upgrades also have added better memory handling in the process and time slicing. So heavy artificial intelligence tasks, they don't time out, and it's only getting exponentially better. Again, this isn't a guarantee of anything, but the design tries to match the speed of artificial intelligence development with a place that can host it without centralized servers, centralized choke points. And here's a real world analogy that always helped me explain this to people outside the tech world. Think about how the electricity grid works. Early on, factories, they had their own generators, which was expensive to run and also unreliable. Then what happened? The big central grid came along and it was cheaper. But if the main plant went down in that central grid, the whole town lost power, complete blackout. Now just imagine a future grid where every house contributes a little and the rules make it sure it stays balanced and secure no matter what happens. That's roughly the shift ICP is aiming for with compute and software. A move from renting space in someone else's building to actually having the whole thing run on a shared, rule-based, decentralized network. It doesn't happen overnight, but the structure is built in its core to support it in its underlying foundation. Another observation also from my traditional market experience during the big shift to cloud computing in the 2010s. I remember this is early on in my career. The companies that provided the actual infrastructure often captured more lasting value than the apps that sat on top of them. I saw investors back in the day, in the early 2010s, who focused only on the flashy apps get burned when the underlying costs or the rules changed. The ones who paid attention to the actual foundation layer tended to think more patiently and generate the better returns over the long run. And that's why looking at how a project handles the full stack, not just the token incentives, feels important when artificial intelligence is growing so fast as it is. And usage in a system like this burns something called cycles. basically, which are just created by converting the token, ICP, and then used for the compute. Some see that as a link between real activity and the token's role, creating a natural balance over time instead of endless new supply. And with Mission 70, it's going to cut that drastically. Let's keep exploring how this contrasts with the Bit Tensor example we started with. Bit Tensor focuses on a marketplace of subnets where, say, different teams contribute our work and earn rewards in the process. Okay, it's great for spreading out, say, the training and inference tasks, and it has attracted a lot of builders, but the recent departure showed that even with strong incentives, certain control points around upgrades and rewards can still become major flashpoints. And ICP avoids that by making the entire environment, including artificial intelligence workflows, live under the same automatic consensus rules. No single team can pause rewards or deprecate tools without broad on-chain agreement. This is fundamental here. That doesn't mean it's perfect or problem-free. Just that design puts the checks at the protocol level rather than in human hands. And for developers, it could mean writing an app once and knowing it will keep running as long as the network lives without worrying about a hosting bill or sudden policy changes. One more, I could tell you one finance story which really sticks with me from my past. Back when decentralized finance was first taken off, I noticed how some early lending platforms looked unstoppable, until they hit governance vote that completely changed the rules overnight. A few big holders steered things completely away, and smaller users felt the impact the hardest, reinforced that the true long-term stability often comes from rules that are hard to change on a whim and visible to everyone. The on-chain DAO in a project like ICP is one attempt at that kind of transparency. It isn't instant democracy, decentralized autonomous, but it tries to make every upgrade audible and automatic once voted through. This is key. As AI keeps getting better and cheaper and more enhanced, the question many people are quietly asking is, where all that new software who actually live and who actually gets to control the value it creates in the process? And it still sits on the same few centralized cloud providers. The old central point state, always in one place, controlled. A full on-chain environment offers one possible alternative where the code, the data, and the user experience, more importantly, stay under the network's shared security. That's not a small difference here. Not at all. It's like moving from renting an apartment to owning the whole building. But the building is maintained by thousands of independent operators following the same rules all the time. And the potential is there for apps that are censorship resistant by design, monetized through the protocol itself, and accessible without extra wallets or logins for basic use. Of course, real adoption depends on many things outside any one project, like developer tools, improving user habits shifting, and the broader market maturing. But I can tell you, from a structural view, institutions that manage large money often move slowly towards new infrastructure. And that's no different with ICP. They watch for years, testing small pieces before committing bigger. And that's why these kinds of shifts can feel quiet at first, even when the tech is already working. It feels like it's never going to happen. But understanding the incentives and the actual co-level design helps separate signal from the daily headline shift and the manipulation in price action, and also encourages patience instead of chasing every new narrative or vaporware project in crypto. That's a lesson I picked up watching traditional markets through multiple cycles. The projects with solid foundations tend to be the ones that still standing when the dust settles, not necessarily the ones with, say, the biggest short-term buzz. So ultimately here, the core message is simple, that in the meeting point of artificial intelligence and blockchain, architecture and governance aren't just technical details. They actually shape what a project can actually deliver over time and will determine its long-term success. And when a team walks away from one network because the control didn't feel shared, it reminds us that promises need matching rules. A project built to run the full software stack, fully on-chain decentralized, tries to address that by removing outside dependencies and spreading decisions across all participants. The key insight is simple, but yet very powerful. Structure matters more than the story when the real pressure hits. This perspective might just change how you actually look at the next wave of tech projects, making you ask better questions instead of chasing the loudest voices in the room. Think about it. The next time, say, you see a new development in the space of crypto or Web3, focusing on the foundations could make all the difference here in understanding what will actually last and what will be here in 10, 15, 20 years' time. And that's the story behind this recent moment in decentralized artificial intelligence and decentralized card infrastructure, as ICP is that only solution. And with that, we wrap up today's journey because everything comes together. And when we step back and look at the core systems instead of the noise and the price action, stay curious, keep asking good questions, and let your own learning continue. Because everything we've explored today, could shift the way you see these technologies forever. And remember, the choices we make today, they might feel like small, but they actually shape tomorrow's story. And if this video actually cut through the noise and actually gave you clarity, not hype, not hopium, we're just spitting the facts, then do 3 things right now. Hit like. So this reaches people who are tired of being misled, and subscribe, because this channel, it is all about understanding here where technology, AI, money, power, and Web3 actually going before the headlines catch up, and comment with what actually clicked for you or what you want broken down next in future videos. I read every single comment if it's of value. And if you want signal instead of noise perspective, instead of panic and clarity before consensus, subscribe now. And if this inspired you, give it a like and share it with someone who might need the same clear view. Drop a comment also below, because I really do read every single one and it helps shape what we cover next. And don't forget to turn on notifications so you catch the next time we break down something important before it becomes the main conversation. Take care out there, and I'll see you in the next one. And more importantly, remember to stay decentralized, and I will see you on the internet computer. Until next time.